Good morning, good afternoon, and good evening. Today we're going to cover the second subtopic of the third topic, thermal physics, which is matter and thermal properties. Thermal expansion of solids, liquids, and gases at constant pressure. Solids. Solids expand slowly when they are heated. When a material expands, its particles do not get any bigger. However, they have more energy, so they can move around more and take up more space. It is difficult for the particles of a solid to push their neighbors aside, so a solid does not expand much. This is because solids' atoms vibrate faster about their fixed positions and push minimally. Solids need to be put at very high temperatures through energy transfer to melt. Liquids. Liquids expand generally faster and more than solids because the bonds between separate molecules are usually less strong. Even though heat is the same, the movement heat causes in liquid particles is more than solids. Examples of liquid expanding too rapidly compared to other liquids are liquid paraffin and petrol. Gases. Gases expand when they are heated. In the picture below, you can see that at first the gas is cold and its particles press weakly on the piston. When the gas is heated though, its particles move faster. Now they push with greater force on the piston and push it upwards. The gas has expanded, so its volume has also increased. The upward force of the gas is balanced by the downward weight of the piston. So, in this situation, the pressure of the gas has remained constant as it has expanded. If the piston did not move, the volume of the gas would remain constant when it was heated, but its pressure would increase. How motion and arrangement of molecules of state of matter affect order of magnitude and expansion. Solids are very close together because the forces between particles are very strong. All solid particles vibrate at a fixed position, and when heated expand less than the other states of matter unless heat, energy transferred, causes the temperature of the solid to reach melting point. Liquid particles are further apart than solids, and the attractive forces between particles are strong enough to hold a specific volume, but not strong enough to keep the molecules sliding over each other. The forces between particles are weaker than solids, but less than gas. That is why it expands more and quicker than solids when heated. Gases are further apart and weakly attracted to each other. Heat causes the molecules to move faster. Heat energy is converted to kinetic energy, which means that the volume of a gas increases more than the volume of a solid. Applications and consequences of thermal expansion. Everyday applications. Rivets, like the one here, are used in shipbuilding. It's the one in the most left. Are used in shipbuilding and other industries to join metal plates. A red-hot rivet is passed through holes in two metal plates and then hammered until the ends are rounded. As the rivet cools, it contracts and pulls the two plates tightly together. A metal lid or cap may stick on a glass jar or bottle and be hard to unscrew. Heating the lid by running hot water over it causes it to expand so that the lid loosens and can be removed. This is very useful. I use it all the time and you should too. A steel tire may be fitted onto the wheel of a railway locomotive while the tire is very hot. It then cools and contracts so that it fits tightly onto the wheel. And then lastly, a bimetallic strip is designed to bend as it gets hot. The strip is made of two metals joined firmly together. One metal expands more rapidly than the other. As the strip is heated, this metal expands rapidly, causing the strip to bend. The metal that expands more is on the outside of the curve because the outer curve is longer than the inner one. These strips are used in devices such as fire alarms and thermostats. Consequences of thermal expansion. Metal bridges and railway lines expand on hot days, and there's danger that they might buckle. To avoid this, bridges are made in sections with expansion joints between the sections. On a hot day, the bridge expands and the gaps between sections decrease. Railway lines are now usually made from a metal alloy that expands very little. On a concrete roadway, like the one shown in the rightmost picture, you may notice that the road surface is in short sections. The gaps between are filled with soft pitch, which becomes squashed as the road expands. Lastly, this one happened to me also. Glass containers may crack when hot liquid is placed in them. This is because the inner surface of the glass expands rapidly before the heat has conducted through to the outer surface. The force of the expansion cracks the glass. To overcome this, there's glass that uses Pyrex, which expands very little on heating. And another alternative is toughened glass, which has been treated with chemicals to reduce the chance of cracking.